Hi, this is John Nix again, and today we're talking about doing vibrato measurements, and this is a different version of VoceVista. This is version 3.4.3b. It was developed by Richard Horn, originally at my request and the request of a few other folks who were interested in doing some vibrato research. And so this has a number of functions that version 3.3 did not have, and I'm going to demonstrate these for you. So first of all, just reviewing, we have the running power spectrum here over on the right-hand side, and then we have the real-time spectrogram on the left-hand side lower, and then in the upper box we have the microphone envelope. So first things first, what we need is a sample that we're going to do some measurements on. So I'm going to sing a note, and then I'll freeze, and then we'll get into doing the analysis. And that should have been something around middle C. As I said on the other video, best to not start doing the measurements right at voice onset. You want to come in about 500 milliseconds or half a second in order to, just allow the voice to kind of stabilize. So here we are. So just looking right here on the screen, you can see that's your time indicator. So we're at 10,230 milliseconds. We're going to go to 10,730 or thereabouts. So I'm going to drag over. Sometimes, there we go, that's close enough. Sometimes it's a little tricky to get it just right, but 500 milliseconds or thereabout usually is plenty. So again, same kind of keystroke procedure as we had on the other software. So you just press Control, Shift, and then click and drag. And now we get that section highlighted. You might notice the previous version did not allow you to take quite as long of a sample. This allows you to take, really, it's about 6 seconds. And there's some reasons behind that, which we'll explain in just a moment. But first of all, we need to select a harmonic that we're going to analyze, and we want to go as high as we can. So here's my fundamental, and second harmonic, third, fourth. I think I can probably get my cursor here around the fifth harmonic. And so I'm just doing a little box there with using my cursor. So that's our fifth harmonic, and now I just say plot, and it, instead of having to indicate which harmonic, there's a little dialogue in here, and so it pops up and asks you. So I'm going to say, okay, that's the fifth harmonic, and that's important because it's then using that information to do some of the frequency calculations. All right, and so now we have kind of an isolated version of that particular harmonic, and again we chose a higher one so that we got as good a frequency resolution as we could get. And now we don't have to worry necessarily about starting on the trough or the peak, because it's going to be it's automatically assigning where the peaks and the troughs are. So down here you can see it's got a mean pitch, 240 mean frequency, 242.3 hertz. Mean vibrato rate. Okay, so it's got that calculated based upon these little markers that it's put in the signal. Okay, now mean vibrato extent. So it's gone through and it's calculated the extent, and now you'll notice this is a bigger number than we saw on the previous version. The previous version of VoceVista, it was the extent around the mean, and here we're getting basically from peak to trough, so the number is basically double. And so what it has done, the software has gone in and it's got the extent for this cycle and the extent for this cycle and the extent for this cycle, and on and on and on and on, and then calculated the mean of that. Okay, so this is our mean vibrato extent, not just the maximum from the entire sample and the minimum from the entire sample, and saying that's the extent. It's actually gone in and we've got each one of those has been measured, and then the mean of all of those in the whole sample taken has been taken. So 187 cents. Remember, that's 100 cents in a semitone, and so we've got a swing of 90 plus cents, or almost a semitone above and below that mean pitch. Now this, and it's displayed not only in cents but also as a percentage. And then here we have vibrato jitter, and it's showing a percentage. So vibrato jitter is the variability in the vibrato. So how long is this vibrato cycle versus how long is this vibrato cycle and this vibrato cycle? And so it's calculated the period, that is how much time it takes to go from the start to the end of each cycle, and it's calculated the period of each one of those cycles that's being analyzed here, and we're getting basically a percentage variability. And 2% is pretty good for an old guy. Now it also has done, and this is just relative SPL, it's also done a SPL extent. And obviously this is no replacement for using a sound level meter for doing sophisticated research, but just kind of to get an idea of about how much the intensity is fluctuating. Maximum was 6 dB, and remember 3 dB is a doubling of intensity. Mean was 2.8%. 2.8 dB. And you can see they also have a dB trace down here in blue on the bottom of the screen. So I'll do the whole procedure one more time. This time I'll pick a higher frequency so we can do a higher harmonic. So again, here's my falsetto voice. With apologies to Ian Howell and other countertenors. Anyway, so now we're going to go in, as I said before, looking at this, the onset of phonation here was 2488, so we're going to go to close to 3,000 milliseconds there. Okay, close enough. So we've gone in our half a second, and now Control Shift, and we're going to click and drag and highlight. And you don't want to go all the way to the end either. You want to go a couple of cycles before the end. And the reason for that is there's been some research done in Sweden that, of course, shows that as we approach offset, that vibrato rate speeds up. And so you want to avoid, if you're trying to get a pretty accurate measurement of what's going on, you don't want to have the onset of sound or the offset of sound skewing your results. Okay, so now I can pick a little higher harmonic. 1, 2, 3, 4, 5. Well, actually, since I doubled the frequency, I'm still only about able to get that much. So we've got the fifth harmonic, and it will ask me. A little dialog box pops up, and we say OK, and now we've got that one extracted from the whole, and we move our cursors just by clicking and dragging to the endpoints, and it automatically then does all the processing for us. So here, mean pitch, 486.7 hertz, mean vibrato rate 4.5 hertz, We've got a little bit narrower extent from the previous time. Remember, it was about 187. So 122 cents from peak to trough. So you can figure, that's 61 cents, or about 2/3 of a semitone above and below the central frequency. And the vibrato jitter is up just slightly, probably because I was in falsetto. I'm maybe a little less stable in that mode. And then the dB extent, again, pretty high there. Probably have some interaction, one of my harmonics, with the first formant of that vowel. So at any rate, that's the procedure, and this was the software that was used in a number of studies that I've been involved with here at University of Texas at San Antonio. We have some articles in the Journal of Singing, one that I was the lead on, and one that one of my graduate students, Randy Wooding, was the lead on, and a number of labs around the country. I know the National Center for Voice and Speech uses this version. So at any rate, I hope you've enjoyed this brief tutorial on doing vibrato measurements in VoceVista, and keep on trucking, folks. Thanks for watching.